Walt Brown was here on this. We put Walt Brown was here on tons of science
I love it.
and discoveries because all scientists work for Walt Brown. All of Walt's supporters knew all along that lightning, electricity creates radioactivity.
Now, Bob, if can I just take you sort of a little bit off track a little bit, but it's still to do with the heat problem.
Sure.
I've heard of, and I think most atheists and evolutionists think of a solution to the heat problem based on just one specific characteristic, but I've heard of boundary conditions.
Oh yeah, yeah.
And most people aren't aware that it's not just one particular factor that's involved in dissipating heat, but there's a number of other ways that the heat could have dissipated and not been a problem.
Well, could we you guys, I know I've heard you talk about engineer Bryan Nickel, aerospace engineer. Could we ask him, now you're getting a little bit more into his domain. I'm a talk show host and a pastor. And
Bryan, come on, Bob.
I need a life. No, really, guys, I need a lifeline here.
We welcome Bryan Nichols.
Well, I just, if it's okay, I just forwarded to him the link you guys gave me to StreamYard to join this interview. And I did ask him last night, I said, Bryan, if I get stuck, will you be available to help me? And he said he'll be at work, but if he possibly could, he'll join in. So the link you gave me, would it work for him if he clicks on it?
Yes, definitely. Yep. And you guys are such a blessing to us. So of course, if he wants to join and add to the discussion, it'd be an honor. Amen.
Well, that's really nice of you guys, and to be so informal, I appreciate that. So while we're seeing if Bryan could call in, mentioning I'm the pastor of Denver Bible Church, guys, I'd like to break some news on your show. We haven't said this on my show yet. It's not hit the news yet. But Denver Bible Church, we have sued the federal government in the state of Colorado for the COVID restrictions they put on our church. And our federal judge, Daniel Domenico, ruled 44-page ruling in our favor. He said, we will prevail on the merits. So he said, members of Denver Bible Church do not have to wear masks, and they don't have to have this arbitrary limit of 50 people in their church. So it's stunning, you know? So the state of Colorado appealed immediately to our 10th Circuit, and the 10th Circuit put a very gentle stay. And they said, well, let's see what develops in Domenico's courtroom. So we have oral arguments scheduled for a week from today. And we just heard from the Attorney General's office in the state of Colorado, 4 attorneys. They called our lead attorney, Rebecca Messel, and they said, Rebecca, you're going to like this news. We're going to concede. We're going to drop our resistance, and you guys won this round.
Wow, you've heard it first on the SFT channel.
Amen. That's awesome.
That's right, awesome. SFT.
Beautiful.
And the reason it appears that they decided to fold their cards is because there was a victory really by an action at the U.S. Supreme Court a couple of weeks ago where churches in Brooklyn, they got a reprieve from Governor Cuomo, Andrew Cuomo's draconian restrictions. They basically won that at the Supreme Court. Even though the whole court didn't hear the case, they won it. And their filing with the U.S. Supreme Court, it cited our Denver Bible Church lawsuit 6 times. And so when our Attorney General saw the writing on the wall that the Supreme Court, at least, you know, all this indication agrees with us, they rather drop the case and let us have a victory now than perhaps we get a victory against them at the U.S. Supreme Court. They didn't want that to happen.
Amen. Well, you heard it here first. That's amazing. That's amazing.
Yeah, super.
And looks like Bryan Nickel Bryan, thank you so much for being here. We appreciate it. We love the work that that you've done. We've learned so much from you. So thanks for being here, Bryan.
Yeah, thank you for having me.
So, Bryan, they asked me a question that I didn't feel qualified to answer. So maybe I think it was George Bond,
Yes,
George
yes.
Bond. Could you put that question to Bryan?
Definitely. Hi, Bryan. I've had a short discussion with you on Messenger at Facebook.
Yeah.
I believe you're working on the ninth edition at the moment, and I'm very eager to see those calculations for the heat problem because I'm a retired civil engineer, so I understand a little bit about mathematics. So I'll be eager to have a look at those. But the question that I posed to Bob actually it wasn't a question, but it was more about the addressing the heat problem, and I'd stated that there's really not one factor that can explain the criticisms towards creationists in this area, but I mentioned boundary conditions. And I'm sure you can expand a bit on boundary conditions and how they actually can be used to solve the heat problem.
Yeah, well, I think it can be used to understand it a little bit better, and to identify where I think a lot of the criticisms of hydroplate theory go wrong. So I I won't say that we can just easily or easily solve the heat problem for hydroplate theory, if you want to call it a heat problem, in terms of having some summation of numbers that just gives us an absolute, oh, this is solved, right? But I think where a lot of the criticisms go wrong is they tend to oversimplify hydroplate to the point that they so that they can analyze it, but then they leave out a whole lot of physics that's happening in the hydroplate scenario. And so I think what you're referring to is boundary conditions in terms of like boundary layers in a high speed flow, things like that. Is that?
Well, I was specifically talking about space being a nearly infinite heat sink. For example, the heated air dramatically cools it as it expands.
Yeah.
I think the other one is cooled particles could fall back onto Earth, neutralizing some of that heat as well.
Yeah.
And of course, the important one, and we all talk about the specific heat capacity of water. That that's another factor that comes into play in terms of neutralizing the heat.
Yeah, I think definitely plays a role in me reaching the conclusion that heat would not be able to transfer to the lower atmosphere in the way that so many critics believe that it did. And so far from critics that I've seen, what they do is they will just take a very simple um, thermodynamics equation that takes the specific heat of water times the mass of the atmosphere, and then they solve basically for what would your final heat be if you added some percentage of kinetic energy that Walt estimates that the fountains needed in order to launch all the asteroids and comets and TNOs. So they'll just arbitrarily pick a seemingly really low percentage of that kinetic energy value, and then they'll apply it to this equation and come up with 3,000, or 300 degrees Fahrenheit increase in temperature of the atmosphere. But they've done that without and that's where they've oversimplified the problem, because they've done that without um, taking into account high speed flow has through a stagnant atmosphere. And that's really where they go wrong. They've oversimplified the problem, and so they've come up with an answer they like, but they've ignored a whole lot of very real physics that would be going on in the interaction between the high speed hypersonic flow of the jetting fountains and the stagnant atmosphere.
So,
And
Bryan, could I ask you the temperature of the water in the subterranean chamber? Walt has indication of how hot the water would have been, and that's why the natural thought is, well, when it's up on the surface, it's going to scald all life to death, even those on the ark. But how hot would the water have been in the chamber when the fountains erupted?
Right. So there's some indications from meteorites having like the iron nickel meteorites having a Widmanstätten pattern in them, and they know that results. To get that, you need prolonged temperatures at 1,300 degrees Fahrenheit. So that a rough estimate is that the waters of the Great Deep were started out below the crust at 1,300 degrees Fahrenheit. And so many critics just assume that 1,300 degrees Fahrenheit is what the atmosphere experienced. But remember, that's 60 to 30 miles below the crust where we're at 1,300 degrees Fahrenheit. But when you allow a high temperature fluid to expand freely, we call that throttling in the engineering business. When it expands freely,
Hey, Bryan, we're getting bad audio from you. Could you begin again? When it expands freely, what happens? We don't have a good connection.
Here, let's try this.
Yeah, it looks like it was about maybe 5 or 6 seconds there with a bad connection, but it looks like, Bryan, looks like you're back.
Yeah. How's that?
Good.
Okay. You'd asked about the high temperatures, 1,300 degree Fahrenheit temperatures of the fountains of the Great Deep. And so many critics assume that 1,300 degrees Fahrenheit will be what the atmosphere experiences. But remember, that's 30 to 60 miles below the surface where those temperatures exist. And when you allow a high temperature, high pressure fluid to freely expand, the expansion itself causes there to be a rapid cooling of the fluid as it accelerates, basically. So in the engineering business, we call that throttling or free expansion through a nozzle. And that is absolutely what happens. I mean, that's relied upon in the physics of a rocket engine or a jet aircraft or anything like that. It is known that when you freely expand a fluid, it is going to cool down. So by the time you expand a fluid 30 to 60 miles, it definitely would have cooled down and gained tremendous kinetic energy by that time. Now, the exact amount of cooling and what the exact temperature is of the flow as it passes by the atmosphere, the lower atmosphere, I can't positively tell you what that would have been, but it certainly wouldn't have been 1,300 degrees Fahrenheit. If you look at the throat of a rocket nozzle, for instance, the temperatures right at the throat are extremely high. And if you follow a plot of how temperature changes as it passes through the throat of a nozzle, like say a rocket nozzle, and enters into the expansion chamber, which is kind of that bell-shaped part of a rocket nozzle, the part that you can see, we know that the temperature drops rapidly from the nozzle. So by the time it exits the bell chamber of the rocket, those temperatures have cooled a tremendous amount. So definitely not 1,300 degrees at the surface of Earth in the lower atmosphere.
Are there any heat problems with the drifting of the continents in the model whatsoever?
Yeah, that's been talked about a lot. I think one of the strengths of hydroplate theory is its explanation of shallow magma under the continents, which I think is actually a problem for other forms of, I'll say, geophysical models. So I think you probably have heard about the fact that magma below the crossover depth cannot rise. So the idea that plumes of magma that could come from the super dense outer liquid core of Earth could rise through the mantle, that is a fantasy as far as physics is concerned. And so where do we get these big calderas like under Yellowstone Park and things? How do we explain that? I think hydroplate theory's strength is in providing a very real mechanism for where that heat came from. So I don't see the heat being a problem for hydroplate theory, simply because, yeah, we have lots of areas where there's tremendous amount of magma somewhere down there about in the region where we would have expected the the granite crust to have crashed into and skidded against the mantle for a certain length of distance, as it slowed down. And so that's where that heat came from. And then, yeah, it melted a whole bunch of rock. And of course, we have a whole bunch of evidence from volcanic mountains, especially for North America here along the western edge of the continent. A lot of those mountains are volcanic, like Mount St. Helens and whatnot. And of course, when they erupt, they send off not just magma, but tremendous amount of steam and carbon dioxide. So that again plays right in with the hydroplate theory as to where that heat came from, why there's all that pressure, why that pressure is still pressurized. And so, yeah, I don't see it as a big problem. When you have tremendous heat, rock also is a great insulator for things that are heat. So yeah, you might have a lot of heat built up under the surface of the continents as they drifted and slid and compressed during the compression event. But the heat that we have down there that we know is shallow really just points to the hydroplate mechanism as a very valid mechanism for that. And it explains why there's that heat at that point in Earth.
Actually, I'd be curious to ask, actually, if I can ask a real quick question, because everything you're saying is awesome and extremely helpful, Bryan. We've got a critic who typically uses arguments from, I'm sure you're aware, Tony Reed, where they say that we require miracles. I don't know if they completely understood everything you were saying, because what you were saying kind of goes against that argument where they say only a miracle can resolve the so-called heat problem, if you want to call it that. Well, is there any validity to that with people like Tony Reed and the critics are saying?
In terms of needing a miracle for hydroplate theory to explain heat, I would say no, we don't need a miracle for that at all. That's I think a lot of that, at least from what I've seen of Tony Reed's commentary on hydroplate, there's definitely some misunderstanding of what hydroplate theory is saying, and I think his videos on the subject, to me, they don't convey that he has grasped what hydroplate theory is about, or the mechanisms in it. That, or he's glossing over. I won't speak for him, but that's what it seems to be. One of those two cases.
Right, I would agree with that. And then they'll say that the removal of the heat, the excess heat, they'll say that only a miracle can explain that, which once again, would you say misunderstands, as you were saying, they're oversimplifying it?
Yeah. In fact, I've been working on a video for about 2 years now to answer this question in a way that will convey the very real sciences behind thermodynamics and heat transfer, and the very real physical phenomena that's happening in the hydroplate scenario, so that there's a more thorough and accurate presentation of hydroplate theory's heat management, we'll call it, because it's not a heat problem. It's just how, heat, these mechanisms generate heat. There's certain mechanisms in hydroplate theory that would generate heat. But then the question is how does that heat move through the system? And what is our heat management say? And so it's not that there's a miracle required or that we have this amount of heat that we just don't know what to do with it. We know exactly how that heat moved around or would have moved around. I think critics tend to kind of jump to the problem before they've bothered to understand the physics that explains the problem.
Hey, Bryan, is Walt Brown qualified to evaluate the heat implications of his hydroplate theory?
That's a good point. I don't know Tony Reed's background or some of these other people's pedigrees who are critiquing hydroplate theory. I mean, certainly physicists should be able to come up with I'll say a more realistic and more fair critique of a heat management of hydroplate theory. But Walt's a mechanical engineer, and I think anybody who's been in the engineering field and interacted with other engineering students, I know I went to Montana State University for my degree in mechanical, and mechanical engineers are one of the most entrenched in the field of thermodynamics and heat transfer of any of the engineering disciplines, really. I mean, other disciplines like, say, for instance, aerodynamics and civil engineering, a lot of times when you have to go to take your thermodynamics courses for your rubric in those fields, you are pretty much very likely going to be having a mechanical engineer as your professor for those classes because thermodynamics is right out of mechanical engineering's wheelhouse. So Walt is eminently qualified for that. He graduated from a little podunk school called Massachusetts Institute of Technology, and he graduated with his PhD there with a focus and emphasis on heat transfer. So Walt is by no means uninformed as far as the heat management in his own theory.
Walt actually worked in MIT's heat transfer lab, and he received his PhD from their heat transfer division in their engineering department. So he really is eminently qualified to consider, and he has throughout the entire development of his model for decades now, considered the heat generation and dissipation of the hydroplate theory.
Yeah. I think people hear mechanical engineering, it sounds like gears, but there's a whole half of the discipline that is dedicated to thermodynamics and heat transfer. So the big part of mechanical engineering.
You said that you were working on a video a while ago, doing all the math calculations. Is that still in the works, or are you still more working on the book?
Well, I've been doing kind of a little of both. I will say the video won't be all the math calculations. It'll have some calculations that just show the percentages of how much area is involved and to give the viewer an understanding of things. It's a lot of things are very difficult to calculate as far as like you just end up making so many assumptions that anybody could sit there and pick apart those assumptions. And so I'm a little hesitant to just, vomit a whole bunch of calculations into a video. I don't think it would help with understanding the concepts. The idea behind this video will be to show the physical interactions that have to take place that we know would have taken place, and just show how those physical interactions are going to severely limit the amount of heat transfer that can happen with the lower atmosphere. And that's the main thing, because most everybody who's critiquing hydroplate theory will just immediately jump to a lot of adjectives describing how Earth would cook or boil or fry or whatever, and so the goal of this video is really just to educate as far as what type of physical phenomena were really truly involved in hydroplate theory, and show how you cannot just take some of the things that hydroplate theory proposes and then simplify it outside of what hydroplate theory proposes, and then come up with some supposed calculation that proves hydroplate theory has a problem. And that's really where I see most of the critiques having real difficulty in terms of being fair to what hydroplate theory is proposing.
Bryan, one of the misconceptions is that this heat occurred on the first day. I mean, the flood occurred over 150 days.
Yeah, that's another.
Are they really taking into account that it wasn't over one day; it was over 150 days?
That's another thing that does come up. Even John Baumgartner has essentially done the equivalent of that, where when he's calculating the amount of energy it would take to produce, I think, all the deuterium that Walt claims, he says, well, if you'd have done that, you would have vaporized, the crust and the oceans and everything. Like, everything would have just been vaporized. And it's kind of interesting that he does that, because Walt, in his book, has a calculation where he did that very thing and said, yeah, if you take it over, zero time, then yeah, you add that much energy all at one time to, this much crustal mass and this much ocean and atmosphere mass, then yeah, it all vaporizes. But if you spread it out over 40 days, suddenly it's not a whole lot more intense than an LED light bulb. So time is a very important factor in this, and I think a lot of critiquers tend to skip that.
One